My name is Robert Hodges, and I'd like to welcome you to our session today. It's going to be presented by Gong and Jove, who are co-founders of Timeplus. They're going to be talking about querying live data using open source SQL engines. So great topic. We've got a lot of real-time and event processing going on today. Love this presentation. Welcome to both of you, and take it away.
Okay, thank you. So yeah, got me from Timeplus, streaming first analytics platform. And in this talk, we're also adding some coffee elements so that you can compare different options. So first off, let's talk about the live data, right? So this is a random report I got from the internet. It is very clear that there's a lot of data generated now and in the future. And at least 1/3 of the data is for the real-time purpose. But today, there's only about 1% of data is analyzed, no matter using code or using SQL. So there's a lot of potential. We can better understanding what's going on by figure out what's data in different message buses. And Kafka, Pulsar, Rapanda, there's many streaming message bus for you to store and transfer data. You use SQL for big data query, right? So the idea we want to present in this talk, that is, you also should using SQL to query the live data. Why? Because it is very reliable for you to using a SQL engine, not try to build your own program by yourself. Otherwise, you might have to handle a lot of memory management, concurrency stuff. But using a robust SQL engine give you a solid foundation for you to do mission critical jobs. And also it can be very fast because the database is implemented by experts with very good understanding about performance, algorithm, data structure. So in many cases, using a SQL engine to query live data will be even faster than if you query using vanilla API from the message bus. And also it will be easier to use, right? So even a kid can write SQL to query data in MySQL, in Postgres, even Hadoop, right? So you can imagine that is, if you choose the right SQL tool, you can also use SQL easily to query whatever data in Rapanda, in Pulsar, in Nets, in MQTT. Even invite an intern to write a SQL to query, to build a dashboard, and this can be easily done in a few days. And it's all very powerful, right? So if you're using the low-level API to get data from the message from the topic, you can easily do some basic stuff like filtering, or flat transformations. But if you need to do powerful data joining or complex event processing, it requires a lot of data management, a lot of algorithm. But SQL is a very good way for you to express those logic. You can do very powerful multi-stream joining. You can have multiple CT or subqueries and present complex event processing or even machine learning. So all those achievable using SQL. Also, the best part is that SQL is a descriptive language. Actually, you tell the system what you want instead of what you want to do one by one, how to do it. So the SQL engine is able to have some query analyzer or query optimizer for you to capture your initial intention using SQL and try to convert it in the most efficient way and put into the database engine so that you just showing your kind of requirement, but the SQL engine will making sure it will use the most efficient way to get the result for you. And here's some sample use cases our team have implemented recently. You can check the link in the Timeplus doc and in the showcase part. There's many different industrials we can apply time analysis using SQL, no matter in the fintech area, even some of our clients using our technology to do real-time pricing or post-trading analysis. Some IoT customers to monitor their feet on the road or the trucks, or monitor thousands of wells in the sites, which need some edge computing and consolidated data back to the central data center or micro data center, including the customer engagement, social listening, or security. So as long as you have fresh data, those data can be analyzed in a better way using SQL and trigger the alert, build the dashboard, and give you a better foundation to make the right decision. But go back to the coffee analogy, that is, there's dozens or even hundreds of ways to make coffees. And yeah, maybe there's a similar different ways to query Kafka or POSA or Kinesis data using SQL. And this is a diagram with some logos grouped by whether it's a streaming processor, whether it's a streaming database, or a real-time database. We only list the open source tools because this is an open source analytics conference. So we are going to go over them quickly and group by language. I know programming language may not be the most critical thing to the first factor to consider, but it means something in some way. So let's go over Java-based system to query data, query live data in SQL. And the first one, of course, is Flink. This is my kind of impression for how Flink is. So it is almost a de facto standard to apply streaming processing on real time, but with a lot of effort and some learning. So it's just like this fancy machine. It is very complex, but if you have the right skill, have a lot of time, you put the money and effort in, and you can come up with a good result. For people who are familiar with Flink, so you know that they have multiple layers, and they provide both Java API and a SQL API. So there's some examples how you can get data from Kafka and query them just using SQL, even apply some join. Right? And also I put a quick note. It's not really a very official note. I just based on our team's experience, because many of our members in Timeplus also use Flink a lot. So Flink has great community for sure. And regarding the low latency and the streaming, it is very powerful. But for example, we from Timeplus, we build even more performance and low latency system. Flink is very good for large scale deployment if you have hundreds of thousands of nodes, but it's not very easy to learn, and it's not lightweight enough. And the other common option you might get is KCQDB. I put this image because it's a kind of a coffee, but with Coke. The reason that is if you get Kafka setup, open source Kafka setup, you can easily combine this together. You can using Kafka as the storage, but using the KCQDB as the computer engine. And assuming all the data is in Kafka, then you can using KCQDB to provide this SQL interface similar to the Flink SQL. You can connect to the different broker, and you can write SQL to query it, even do some join. Yeah, this project has been there for quite a while, and but there are some limitations. For example, if all the data have to be in Kafka, say if your data is in some other places, such as Kinesis or POSA, this may not work. And also saving all the data in Kafka, say multiple months, multiple years in Kafka, is not very practical, or can be very expensive at least, even with the tier storage. So you have to balance how many data want to be queried using KCQDB. You cannot query a lot of historical data in KCQDB. It will also add a lot of new topics in the Kafka and some extra cost. The other option I want to mention is Hazelcast. Is again, it's also a Java-based system. One of the interesting design, they have memory-based computing, but they have figured out a way to leverage a cluster to share the memory. And the similar thing that is, you can define all different SQLs to connect to your Kafka or POSA and query it. Moving next is more about a real-time database. So they don't really provide a streaming semantics. When I say real-time vs streaming, that is for system like Pinode. I think also share Druid his example. I'm not going to go into details. So these systems are OLAP database, but if you want to get the latest event, you have to keep a query over again. So you send the query every second, every 2 seconds. But they have they're coming from the database side, but they are adding some real-time features on it. But compared to Flink or Proton, which will be talked about later, it's not streaming, so it's hard to do some stateful processing. And I will skip the Trino. Trino, again, it's a federation search. So it's just like the Kafka, that is that they don't really have the data. They actually push the SQL to the underlying systems to let the downstream to carry the data for you, and they provide a unified query interface for you. But they don't really have any coffee in it. So that's why I'm using the Kafka. So moving next, we are talking about some system implemented using Timeplus, and I will hand over to Gang, our CTO, and talk about Proton, our own project first.
Thanks, Jove. Thanks for having us. So next, I'm going to quick talk about some other options, open source options. The first one is Proton, which is a C++ based streaming processing system. This is the architecture of Proton, right? If you take a look at this architecture, actually, it's similar like the human brain, right? We talk about the streaming processing and historical storage. Quick highlight of this architecture is we have two storage, right? Streaming storage and historical storage. The streaming storage is something like a pen-only log. It's similar to Kafka, but it's internal in Proton. And the historical storage is ClearHouse. Actually, it's a OLAP column database, right? So why we have these two storage together is actually because if you do data analysis, right, if you're processing data, there are actually two ways to make it fast. The first direction is actually using streaming processing. As soon as the data comes, you do incremental stateful processing and emit processing result as soon as data comes, right? But the limitation of the streaming processing is that you cannot scan a large amount of historical data because scan data on a pen-only log usually is slow, right? The other direction is actually leverage the OLAP column database, where you can scan a large amount of data to aggregation super fast because of the column style. But both of these has limitation because with historical data processing like OLAP, the real-time data, the fresh data cannot be easily handled because you need to index data, you need to merge data some way, right? So that's why actually we designed this Proton, like a unified storage, similar like the Daniel Kahneman's book, like thinking fast and slow, right? Like human brain, we have two systems. The system one is make super fast instant decision making, and system makes some logic analysis, a lot of historical data, right? So we can think that when take Proton as your brain and streaming processing is the system one, make immediately actions on your fresh data. And historical data is actually the system two that make analytic on large amount of historical data, right? And we actually unify this together with the SQL engine. You actually can query this data using SQL. So here's the sample that you can create. When talking about the query Kafka data in live, like we can create, in this case, using Proton, you actually can just create this external stream. So the external stream is actually, we don't store, there's no persistent data. So data directly come to the query engine. And we query the Kafka data, run just a SQL, and emit the result to analytical result. Of course, actually, because we have two storage, right? Actually, you can create a materials view to save those Kafka data or query result internally as a material view. So that's the case where that's actually the two systems, system one and system two, actually work together, right? Both systems are good. But if you combine the two systems, it's even better because you can make decision on both the fresh data and the historical data, right? So Joe showed us some of the query samples, right? We can quickly go through them. The first one is the streaming tail. It's similar like the car live data is just a stream, data stream. And if you run this start from the car live data, it's actually push all the fresh data to you. As soon as there's new data from this live stream, it push to you. And this is the system one, right? The historical query, actually the system two, actually you can see we add a table function to this stream. Actually, we turn the streaming data to a historical snapshot. That means give me all the historical data, all what happened in the past, like do a thorough analysis on all the data, right? And there's some others like a global aggregation, continuously do aggregations, window aggregation, group data in a window. It's quite typical in stream processing, right? We also can do substream like partition by specific car ID, and then actually we gave you a lot. We analysis all the data as a substream, all the cars at the same time. Of course, there's watermarks processing because in the stream processing we process a late event, and we can like travel. The time travel here is actually we seek historical data. When we processing data, we go back to a specific time offset. And the complex part is like a drawing, right? We can join the stream. You can join the stream to table. So, but that's all supported in Proton. So by all these functionalities, actually, you can query your Kafka data with so very complicated SQL functions. Joe is a coffee lover, so we compared to coffee. Like we think Proton is like something like a mocha, because it's a combination of the coffee and hot chocolate, right? It's like two systems. And we do have some coffee notes, but we can skip this part. Maybe later on, Joe will have a summary on all the coffee notes, right? So if you do want to try this function, there's actually a time cloud version of Proton, which is Timeplus cloud. So you can try all the functions here, and there's a lot of UI. It support different data sources, support the interactive queries, data lineage, and a lot of other functions. So this is something built on top of this open source Proton. For sure, there's other options, like Proton is built on top of ClickHouse. You actually can run query your Kafka data on ClickHouse as well. But here is a sample that you create a table engine called Kafka table engine and query data on Kafka, right? You actually can do that with ClickHouse. But the difference is that the ClickHouse is like an OLAP database, only the historical one, right? It takes all your Kafka data as a table, like a snapshot. So that means it doesn't have any incremental streaming processing. As Proton is built on top of ClickHouse, we actually have a PR that we can contribute our stream processing part, the Kafka part, back to ClickHouse. Maybe later on you can do the same thing in ClickHouse. The other option, open source option, you can query Kafka data is actually StarRocks, right? StarRocks is built on top of an open source database, but with StarRocks, you actually can just ingest Kafka data instead of query Kafka. That's the difference, right? Okay, there's some other options built on top of Rust. Let's quickly go through them. So the first one is Arroyo. So Arroyo is like a Rust-based data pipeline. You actually can create a data connect, be the connector of Kafka source, right? Then you can, this connector will connect the Kafka data and you can query it. So here's the sample that you can run query something from this other topic. Another one, which is actually, you probably already noticed, this Rising Wave. Rising Wave is built is a Rust-based streaming database, right? If you query, like today's topic is about query live Kafka data. So that's why the Rising Wave actually is an option, because it's also a stream processing. You can create a table based on the Kafka connector, and you can run the query, all the stream query. The difference compare this Rising Wave and the other one, the Proton, is actually Rising Wave give you the query itself is still bounded, right? But if you create the material view, it's actually incremental processing at the background. So when you're using Rising Wave, it's actually same as your other database experience when you query Kafka data.
Yeah, and the other thing I want to mention that is Rising Wave still using a role-based storage. Mm-hmm. But for Timeplus or Proton, we actually leverage ClickHouse. It's column-based, so it's a much mature and fast OLAP. Right. You can query a lot of historical data without to worry about performance.
But I really love both the Proton and Rising Wave, because with these streaming database options, it's simple. You just create a table, run a query. That's very simple, right? This is the benefit of both. I'll give it back to Jove. Jove may make some summary on all these options. Which one you can see there's a lot of options to use for if you query open source data on Kafka.
So compared to the previous logos, I add some other options. So if you go beyond open source, so if you're okay to use some cloud offering or some even non-SQL based solutions like Biwex, so there's really a lot of way for you to query data, live data in SQL or in other tools. I guess the key point that is this is really a good time for us to embrace data in motion area. And also, as our mission explained, that is, we really want to give you a unified tool to query both historical data and the real-time data, and try choose the right tool for you with the minimal learning curve, minimal infrastructure investment to get started to implement some of the new ideas. So each tool may have different focus. So for example, Flink is really focusing on large scale deployment, but it's based on JVM, and you might need to write some code, do some tuning. KCDB is based on assumption that all the data is in Kafka. Proton, we take a very ambitious goal to have focus a lot on the simplicity, as simple as a single binary, And we focus a lot on the performance side and provide a unified capability for both real-time data and streaming data, and the other system like Rising Wave or Biowax. The key point that is go check different tools, and based on your team's skill set, for example, whether your team is more prefer using SQL or using Python, do you want to using on-prem deployment, want to use the cloud, do you care a lot on the real-time side or care about the historical side? Based on your team's unique need, try those open source tools and figure out which one can work best for you. Just like coffee, that is, there's so many different coffees. You can try different ones and find which one works best for you. Or even you can try different coffees in different days or even different time of the day. So that's conclude our talk, and we'll be more than happy to answer any questions if you have. Yeah, thank you. And by the way, give us a star on our repo. That'll be really appreciated.
Oh, yeah, great. Thank you. I'm back here. Thank you so much for that talk. Sorry, I had a brief glitch getting back online. Yeah, we do have a couple of questions for you, and we have time to answer them. So timing was perfect. The first question was a question from Manju. For Kafka, do we need a separate server for each topic? And I think that may have been related to Proton, but that popped up about 10 minutes ago.
So in Proton, we just need access to the broker and the topic name. Right, so every single topic, no matter how many partitions you have, it will be put into the single stream. Even we have some advanced setting that is only want to read a particular partition, it's also doable. But it is not really a good practice to connect multiple Kafka topic and put into the same stream. You can do so in Proton. Nothing prevents you, but you might end up with different schema. So it's really, the short answer, it really depends on your use case. But in general, we don't recommend put all the different topic into a single stream.
Okay, great. Here's another one. Do you offer a Kubernetes operator or Helm chart, and do you consider Timeplus production ready?
Yes, Timeplus is production ready for sure, and we have some customers even in the most mission critical side on the fintech doing pricing or algorithm-based trading with us. So Proton is a Apache 2 license and focus a lot on the easy to use, and we do have a cluster feature available on our commercial side, and even using open source Proton, you can actually leverage Kafka as the way to do the clustering and the filtering. For example, like multiple Proton can read from the same Kafka topic using the consumer group, and if one fell down, the other can take over. But you can also check our commercial offering, no matter it's for the cloud or from on-prem deployment.
Yeah, and Helm chart or operator, are those available?
Yes, we only provide .compose today, but we can easily come up with some Helm chart or operator. But again, regarding the cluster, that's depends on how you want to do it. So if you're okay to use Kafka as the coordinator, then you can just set multiple replica for the Proton. But if you want a more native clustering, you can talk to us. We can arrange some talk. Yeah.
Okay. Yeah, and you mentioned in your talk, this is just a question from me, that you have a PR to put some form of stream processing into ClickHouse. Could you talk a little bit about that? What exactly is this, and how does it work?
Yeah, I can talk about that. So we sent a few PR. One of the most recent one is to enhance the Kafka engine of ClickHouse, so that we can do incremental updates. So, for example, you can get how many new events coming to this Kafka topic just using ClickHouse. So this is what we call global aggregation. So, so it will be our first attempt to integrate such a streaming SQL to the ClickHouse community. But even so, we have a lot of discussions or refinement. But our goal is to we share all our lesson learns or our designs to the ClickHouse community, so that more users on the ClickHouse side can benefit from this new streaming SQL. But in the same time, Proton can move very fast. We introducing a lot of new features, even new semantics in Proton. And when some features can be integrated back to ClickHouse, we'll be more than happy to work with ClickHouse team to do that.
Great. Yeah, because ClickHouse does have some stream processing features. Like there's a feature called Live Views that does allow you to watch new data. Definitely really interesting that you all are working, though, on the Kafka side. I'm just looking at the questions here. I think we are done and we're at time. So I'd like to thank you both again for doing a great talk. Thanks for a wonderful overview. I already seen one thanks from the crowd. And yeah, pleasure to have you here today. Thanks again.
Thank you, Robert. Thank you, everyone. Yeah.
Thank you, Robert.
All right.
Thank you for having
Bye-bye.
us.